My name is Justin Brooks. My background is actually in mechanical engineering, but I've spent some time working with various LiDAR manufacturers and spent some time on the ground actually delivering this type of data to, DOTs and big utility firms. So now I'm working with Trimble to, assist the dealers and our customers in utilizing this technology as much as possible. So this is a great follow-up to Mike's presentation there. But we kind of maybe take that a step further for more generalized applications there. So we'll dive through some of these. But first, for the general mobile mapping portfolio here at Trimble, we've recently reduced it to just these two systems. We have the Trimble MX60 and then the MX90. I'll dive into some of the key differences here in a moment, but mostly you could see right away this laser scanners on there. The MX60 is utilizing the Trimble profiler, similar to that of the X9, while the MX90 has the Regal profilers that are much longer range and higher density. We'll dive into a little bit of these. First, I like to give a overall technology review of things that are common on both systems, frankly. And it is good to know, at least it's coming from a base level of knowledge on what these systems are capable of and what to look for if you're kind of out, searching these systems or looking around at this type of technology. First, of course, we have the LiDAR scanners themselves. LiDAR is light detection and ranging, as we kind of brought up earlier today. It's essentially a laser rangefinder that allows you to get really accurate ranging information and intensity information from a laser. But instead of a single pulse, it's shooting out roughly, a million plus points per second in a full 360. So as we drive down the road with this thing on a vehicle or a boat or, any kind of moving platform, you're going to be mapping out the entire world around you, that anything within line of sight. But this goes hand in hand with an IMU and a GNSS receiver. So the IMU is going to be our inertial measurement unit. That's essentially our, gyroscope and accelerometer. That's really going to help us determine our orientation of the system. And then the GNSS receiver is for the position of the system, obviously. So with that, we're getting an accurate, angle, orientation, and position for every single LiDAR pulse that's shot out. So again, we can build that really, high context, high fidelity 3D environment with just this, single pass down the road. And all this is in conjunction with a few different cameras to help build that, RGB colorization of the point cloud if you want to, or just more context. And you'll see as we dive into TBC, I'll probably cut down my live demo portion a little bit here just to save time. But using the cameras and the LiDAR scanners in conjunction allows you to kind of pull out a lot more information when you're trying to, determine your intelligence that you want to gather from the data set here. And a few other key components that we like to talk about are, the power unit. Essentially, you could set these things up to just the onboard power of the vehicle. You don't need any dedicated batteries per se, but if you do want to set up on like an off-road vehicle like this, or even little John boats or rail cars, you can use a series of like deep cycle marine batteries, getting roughly, 3 to 4 hours per battery there. But this power unit is really going to streamline and step up the power so it gives the system everything that it needs without any hiccups or fluctuations there. We also have our control unit that houses it's going to be the brain of all of the cables and houses a lot of the storage as well. We have 2 x 2 4 terabyte drives. So, we have 8 terabytes of data that you could potentially capture in this one system. We often recommend that, customers have a spare set as well so that they can just hop swap them at the end of the day. But we're dealing with an incredible amount of data here, guys. So data management does become important now when we're dealing with this much information. We do have a roof rack that is common between both the MX60 and the MX90. So as long as you have 2 parallel bars, you can mount this rack on there, and it has redundant locking mechanisms to make sure that that system isn't going anywhere. Finally here, we say optional, but I do recommend both GAMS and DMI. The DMI is a distance measurement indicator we can kind of see on the wheel well here. It's going to track not only your distance traveled, but more importantly, when your vehicle comes to a complete stop, and it'll kind of tell the system that to prevent, logging extra LiDAR data or prevent the IMU from drifting around. So out in open sky, open highway, these components aren't critical, but if you're ever in like a dense city environment or GNSS denied areas, that DMI is going to come in handy, as well as the GAMS, which is like a secondary heading antenna. That's just really going to help you track which direction you're traveling in and lock down that much faster. So again, these aren't absolutely critical in open sky, but I do recommend them for any type of GNSS denied environments. and dive in a little bit more specifics on the MX90 and MX60. But I will fly through these a little quickly here, guys. So please feel free to ask questions at the end if you want me to dive into more detail. But just as I broke down those individual components for, mobile mapping or kinematic LiDAR collection in general, here's where we can kind of point to each of those components on the 90 itself. We have the 72 megapixel Ladybug 6 camera up top here with that primary GNSS antenna right up top. We have a fiber optic gyro IMU in there, which is amongst the highest level IMU on the market. Anything more accurate would be essentially, ITAR restricted military grade technology. So we're dealing with very accurate, very precise systems here. Obviously, the two LiDAR scanners right up front sticking out. And one thing that the MX90 has that the 60 doesn't are these forward-facing planar cameras. So this just gives you more context, sharper imagery for reading things like, small details on signs, lettering, even tags on utility poles, you name it. These cameras are only 12 megapixel, but with the field of view, it's pretty sharp image still. We also have a backward down-facing 12 megapixel image down here, and that's more for pavement analysis, pavement condition stuff that we'll talk about here in a moment as well. And here is that universal mount that I spoke of. Now, one interesting point with these mounts is they have these little survey marks on here. Oftentimes when we're measuring additional components like the DMI or GAMs, or even some customers opt for higher resolution imagery that they'd like to hook up, thermal imagery. Oftentimes you need to know the offsets to the IMU, which is kind of like the heart of the system. And we've made that really easy now with these survey marks just on the side of the mount here. You can measure all of your additional components right to this, and then we know the precise offsets right to the heart of the IMU there. But here's some key specs that we like to highlight here for the 90. It is pushing out roughly 3.6 million points per second at 500 lines per second. So you'll kind of see in the data in the back end how dense these point clouds are. Even with a single pass at highway speeds, you'll be capturing an incredible amount of detail. The precision on these is roughly 3 mils with an accuracy of 5 mils for like kind of max range of the Regal sensor there. I should also mention that it's reaching out to upwards of 400 meters now on this newest Regal sensor. So it's an incredible amount of data at really long distance. I think that's usually overkill for a lot of the corridor mapping that we're doing, but it can definitely come into handy with a lot of these utility type projects trying to capture power lines that are way offset from the road stuff, for example. We do have those two 4 terabyte hard drives, as I mentioned earlier, with that Ladybug camera and the 3 planar cameras on there. It also is worth noting some of our environmental protections. If you get stuck out in the rain or snow, you're not necessarily going to, brick the system, but you do want to be careful at anything that would be considered a water jet. So if you're driving down a highway and it starts dumping rain, maybe you want to pull off and get under some cover if need be. But we've had definitely customers test the limit on this and push it through all types of very challenging environments. And quickly now with the 60, there are 3 different types of the MX60 here. So just a quick layout, we do have the AP plus 50 for the bottom 2, and that same AP plus 60 that's in the MX90 will also be represented in the MX60 Premium. And then, of course, the old Ladybug camera is in the lowest version, and then the newest Ladybug 6 is for the Pro and Premium. So slight differences here, quite a bit of difference in cost. But we tried to set this up for a variety of applications and price points. So between, at the lowest end with the MX60 core, all the way up to the MX90, we have a variety of solutions for various applications. And here's a kind of similar layout here. Big differences is the no forward-facing cameras. And it could be either a fiber optic IMU or a MEMS IMU, depending on if you choose that AP50 or AP60 there. So I won't spend much time on these, but obviously, guys, if you want a spec sheet here, I could provide these slides or definitely answer more questions later. The big note here, too, is that the X9 profilers, they're roughly getting out, 500,000 or 1 million points per second total, where the MX90 was doing 3.6 million points per second total. So again, there is quite of a difference in the laser scan density, how many points you'll have on the ground per meter. And the max range is roughly, 110 meters with the MX60 versus the 400 on the 90. But something that I find interesting is our precision is actually better with the MX60 because we're using that X9 profiler. We actually have a sharper point cloud. And the way this will manifest itself in the real world is if you take a really thin cross section, for example, of a wall or the road surface, you'll get, with the MX90, roughly that 5 millimeters plus or minus of fuzz in the, laser data, where the MX60 data is much sharper. So even though it's a cheaper solution, the precision is quite a bit better. And then similar things here with the storage, 360 camera, and that backward down facing camera. And yeah, these highlight some of the differences there. In case you were wondering, that is the X9P that we use on our static scanners. The Regal Vux 1HA is the long range mobile scanner that we're using on the 90, and the 3 planar cameras versus the one on the 90/60 there. And here's a quick little just video of our capture software. I like to highlight this because it's come so far and it's so easy to use now compared to the days where I used to have to integrate these systems, from individual components, and the field capture software was a bit of a mess. You didn't always know what you were capturing. Now it's so easy to use, guys. I could usually get a team up and running within an hour of getting their system set up. And as you can see here, it kind of gives you a little bit of everything from all of your images that you're collecting here to your nav data. So you'll get your position and attitude and heading, all of these things in real time. So you can determine if you're getting the accuracies that you need right in the field. You also have a sky plot of all your satellites that are being observed, the optional components as needed. All of this stuff is very easy to see right in the field. As you can see here, we could also upload a background map and or KML files of your boundaries, control points, anything you might need to ensure that you're capturing all the data you need to, so you could prevent any need for, redeployment or remobilization. Can essentially save a lot of time and money by having these simple interfaces here. So I could definitely dive deeper into the collection side. I have a bunch of demos that we could show, but I think this little video does kind of shows a good portion of it here. And we also usually set up a few settings in training. So the operator in the field only needs to choose from a drop-down menu, essentially the type of vehicle they're using and how fast they'd like to take photos and scan. Other than that, it's very easy to set up in the field where, the big green button means go, the big red button means stop, and you basically drive around until you capture all the data you need. So very simple interface here that has come a long way since I started. Now, also with that, we'd like to highlight some of the top applications, but you'll see some of these back in TBC as well. Each one of those systems, as I said, kind of fits into a specific type of application, but really it can be used across the board here, from paving and utilities and fiber to road conditioning and road condition and all types of road asset management, to also rail, of course, rail geometries, rail asset management as well. So I'm trying to save some time here, guys, but I'll fly through these quickly. As far as, road infrastructure, definitely good for inspecting road conditions, identifying cracks or anomalies and other distresses in the road. You could easily extract things, like signs, markers, road paint, all of these things you could pull out now right in TBC. We used to have a separate software that we'd use for what we call extraction that Mike led to a little bit in the last presentation, where it's essentially we have this beautiful 3D point cloud. It's like, now what, right? Like, what do we do with this to pull out the intelligence that we need? Well, TBC has some built-in tools now, as Mike mentioned, to manually draw, right on the point cloud and extract out that intelligence. Or we have some automated tools too that I'll kind of delve into quickly that helps us pull out things quicker, and especially at scale. Imagine you're a DOT, have a 100+ mile road project. It'd be really difficult to go through and pull out every sign individually, or the 100 miles of lane lines manually. Now we could speed that up with a lot of these machine learning and AI tools. And city and urban asset management, this is great for optimizing routes, mainly for surveying and assessing the condition of existing infrastructure. Definitely easily identifying certain areas that might need to be prioritized for repair and maintenance. Obviously, pulling out things like signs, poles, trees, curb and gutter, all of that kind of stuff we can pull out pretty easily now with this one system, and essentially bring the infield survey back to the office, right? And keep people safe and do it at a much faster rate, essentially, that you'd be able to do these things conventionally. And rail infrastructure, we could take this a bit further even if we start to integrate like our Guido scan and Guido software side of Trimble as well. But essentially, you could put this thing on a push cart, or a rail car, can mount it right to the back of a rail car, or a high rail, truck setup, and just scan right down the rail and monitor track condition, signal signs, all the comm systems. You could definitely get a detailed analysis of all of the assets along the rail and overhead, as you can see here from the photo. So a lot of different information you can pull out with just a single pass down the rail without having to shut down, rail operations, which can be very timely and very costly for, doing things the conventional way. So a lot of times now you could throw these things right on the back of a rail car and capture everything you need to prevent any shutdown at all. And a big one this year we've been leaning into is fiber to home and some of the utilities, especially, power distribution, power transmission. Being able to map out all these poles, the locations, the heights, who owns each point or each section of the pole with these, joint use pole audits. All of these things now traditionally were very time consuming and were very, dangerous in even a lot of cases. Now you could do these things from the safety of your vehicle, or even if you have to hook it up to an off-road vehicle or UTV. Now you can just drive down the corridor and kind of extract out everything you might need and take that back to the office, as I said. So really interesting here application that we are developing further. And we got some interesting tools in TBC to take this a step beyond and increase that productivity. But that's a big one that I've been leaning into this year. And finally, the mining applications. Now, historically, these have been, kind of captured by more static scanning, but we are now starting to see more and more these massive mines that are wanting mobile scanners as well to capture their stockpiles and compute the volumes, and even their roads going into and out of the mines, being able to maintain and fix those as needed, inspect the reality against the design, and analyze these cut fill requirements. Now we can create these heat maps right in TBC with various surfaces that are pretty cool. And we can combine this again with static and UAV data, and you can bring it all right into one place with Trimble Business Center and use all of this information in one place to really make better decisions and keep people safe. And finally, kind of goes hand in hand with the road infrastructure, but tunneling can definitely capture and manage utilities within the tunnels, monitor the structural health as far as like any cracking or deformations. The LiDAR data is precise enough to kind of see those things quickly and find them in near real time with some of our change detection software. And obviously like condition assessments. And this is where it gets really important, guys, to use some of those quote unquote optional accessories I was mentioning with GAMs and DMI. It'll really help you in these types of environments where you have no GNSS whatsoever, right? So then you're going to really rely on the IMU, and kind of how you set up the project goes a long way. And please, if you guys ever have interesting projects or challenging projects that come up, please feel free to reach out to Monson or Trimble. We could certainly help you guys with that, because this is stuff that I love to work with and find, definitely challenging. Certainly a LiDAR nerd here. And I think I have a few minutes here, guys, if I could dive into some of the data too. Or Troy, what do you think? I got a few minutes left.
Actually, if you wouldn't mind, we have a question for you, Justin, that we'd like to give you real quick.
Sure, absolutely.
And then we probably do need to move on to the next presentation, actually. But
No
the
worries.
question comes from Matthew Stones. How does the crack detection compare to something that he's referring to as laser crack measurement system? And could
Yes,
this be, yeah.
that is a great point. It's still, I would say that is limited to like a small section of the road, right? But they have a much more precise laser, and to have those LMS systems, they are going to give you a better prior result of, your crack anomalies in the road, especially if they're very tiny cracks. But what we have here is we use a combination of the LiDAR data and the imagery to detect these things, any distresses that are, I think, over 4 mils or so. So I'd say that ours are better for large scale, big context, and capturing everything else outside of just the pavement, right? So now we can start to combine all of these things together. But compared to a traditional LMS system, this is a tool for the toolbox. I'd say that might perform that specific task better, but then you're missing out on all the full context of everything else. And also note too, if I did have more time, could take some cross sections of the road. We are getting a wider swath of the road surface with just a single pass, when, as I mentioned, some of those systems are only looking for a very small section of road. So you have to do way more driving down every lane of the highway and things along those lines, when this might speed up the process. So as always, it depends on what your ultimate deliverable is and what your accuracy requirements will be. But we are starting to push out some of those systems now, even though those have a specific application, just because of our general use here and general utility that comes with having the full context of the full 360 point cloud. That makes sense.